Okay, question 9. Nice question. We've got a little bit on momentum and change of momentum and forces. And then we've got the F equals ma practical, which is really important. So an atom's got this mass in kilograms, perfect. Moving with a velocity of 480 meters per second, perfect. That's what I want to calculate momentum. So magic, puking vampire, delta P equals m times v. So multiply those two together and we get 3.168 times 10 to the minus 23. So that's quite nice. Okay, next one. A ball before and after it collides with the wall. So this is before, so that's U. This is after, V. The arrows show the direction. Before the collision, the momentum is positive 0.80. After the collision, the momentum is 0.60. Well, it's moving backwards and it's a vector quantity. And I'll write the unit there, kilogram meters per second. The ball is in contact with the wall for 70 milliseconds. So divide by 1,000 equals 0.07 seconds. So unit change there. Use the equation. So we're going to need our F equals mv minus mu all divided by t. And to find it from your list of equations, you know, we've got two sets of momentum. We've got a time. So you should have been able to pick, and they want you to work out the force. So put that all together. We can see we've got negative 0.60 final. That's that bit. Because that is the momentum. That is the mass times velocity. They've given it to you. Subtract positive value. So it's to subtract the 0.80. That's this bit here. All divided by the time, 0.07. And we get minus 20 newtons. Okay, this one I'm just going to whiz through because we've done this to death and you are really good at it now. Newton's second law can be stated as force equals mass times acceleration. So we've said if the forces are balanced, an object will accelerate according to the force divided by the mass. And this is actually the inertial mass. Okay, well, the inertial mass equals F over A. But anyway, let's get rid of that bit because we don't need it. So describe the procedure the student could use to investigate how the acceleration depends on the force. So clearly we're going to need a piece of string and a pulley. We're going to attach some masses. We're going to put an interrupt card and we're going to have two light gates. This to measure the initial velocity, that to measure the final velocity. We know the acceleration equals v minus u over t. So my light gates will also find the time in between the two. So that's it in a nutshell. I know I'm whizzing through it quickly, but we have done this loads and you are very good at it. So attach an interrupt card to the trolley and set up two light gates at the start and at the end. Use string and a pulley to attach increasing weights, 1, 2, 3, 4, 5, 6 newtons, so that gravity can produce a force on the trolley. Next part, find out the mass of the trolley using a balance. Read the final velocity v and the initial velocity u from the light gates. Also find out the time it took to get those two. Calculate acceleration using a equals v minus u over t. And then the last part is plot a graph of force versus acceleration. And this should give you a linear relationship upwards. And I'm just going to add in here and the time. And there we go. Common question, and I know you're pretty good at it.